Hi everyone, this is ABAQUS, and here in this video we are going to simulate a 4-floor building in the ABAQUS software. And this building is going to be under seismic earthquake loadings. So first we start from the part and we are model our building. First click on the create part, and here we have three-dimensional model, deformable and solid. Click on continue. Click on create rectangle and draw a simple rectangle here, and apply dimension. Here is 15.5 meters, and here should be 20 meters. Okay, and I'll select this one and click on done and apply also 20 meters for the depths as well. Click on OK. So now we have to create using create cut. Click on create cut and choose this face and this line. Okay, here draw some rectangles like this one, and also this one. Okay, let's apply some dimensions. Here should be 0.5. okay, here is 0.5 as well, and also here is 0.5 as well, still here 0.5. okay, now we can add some constraints. Use equal lengths and choose these lines as equal lines. Click mid click and also choose these lines. Okay, as mid click, then click on done. Okay, and then apply the length. Here is 4.5 meters. Okay, this line is also 6 meters, as you can see, but I'm not going to apply this 6 because it's already 6 then, and as you can see, the lines are all green, which means that this is already defined. Okay, now let's draw some other parts, rectangles also here, and here the dimension is 0.5, all are 0.5, and also this one 0.5. okay, 0.5, 0.5, okay, and apply equal lengths for these lengths. This one push shift and apply for the other lines as well. Okay, click on done and apply the equal lengths condition for also these lines. Okay, now apply the dimension. Here is 3, and as you can see, these rectangles are turned to green, which means that these lines already determine the dimensions and the location is true. Also, I'm going to draw 3 rectangles as you can see here and apply the dimension. .5 here, 0.5 here. This length is 0.5. Same. Okay. Okay. Yellow color means that you have to add some other constraints here. Let's try with the length of here, which is 3 meters. 3. Now it's okay. Let's go to the 4th floor. Draw 3 rectangles like this. Okay. Also, we are going to use equal lengths here. These lengths are same, equal to each other. Click done. Okay. Now we have to choose these lines as well. Done. Okay. And now we have to add dimensions. Okay, and add the dimension for this length, which is 3 meters. Okay, now it's done, and click on done. And here for extrude cut, you have to select through all and click on OK. Okay, as you can see, the building is going to have its own shape. The same thing is done in this side. And here we are going to click on extrude cuts, choose this face, and then choose this line. Now I'm going to do it fast and you can follow me. 4.5. Now we are going to the second floor. Here we are going to add some dimensions. These are equal lengths, and also these lengths are also equal. Okay, now we have to add some dimensions here. To turn all the shapes into green. This is already done. Yeah, you can go back by Ctrl Z. Also, here is 3. Okay, now we are going to the next floor. Choosing the equal lengths also. Choosing these lines. Done. And these 3 lines as well. Done. Okay. Apply 3 meter for this line. It's okay. Now we are going to build the last floor. Zero 0.5, 0.5, also here 0.5. Okay, this length is also 0.5. Okay. Okay, it's done. Click on done and then okay here. Now as you can see we made a 4-floor building here. Then we can go to the property. Here in the property you can insert the material property of the concrete. I am going to write concrete. Here. And click on mechanical elasticity, elastic. The concrete young modulus is almost between 15 to around 40 gigapascal, but here we insert 30 gigapascal, which is 30 E9, and the Poisson ratio is almost 0.2, and then we are going to add the density. The density is 2400 kilogram per cubic meter. Click on OK, and here we have to create a section concrete as well, which is a solid, homogeneous. Continue and click on OK. Then assign it to this structure. Click here and apply. And here click OK. Then you can see the figure is going to turn to green. Okay, which means the material property of the concrete is completely assigned for this structure. Now we are going to the assembly part, and here insert the structure on the assembly part and click on OK. Then we go to the step modulus, and here in the step modulus you have to create a step. For this step you can name it as an earthquake. Okay, which is a dynamic explicit analysis. Here click on continue, and here you have to insert the time period, which is the earthquake time. I have the data of the earthquake of Quebec City in the Canada, which was in the year of 2005. The maximum amount of acceleration of this earthquake was 0.4 G. G is the Earth's gravity, Okay, I'm going to apply this diagram into the into our analysis. From this diagram, we know that the amount of the earthquake time period is 20 seconds. Then I apply 20 seconds here. Also, this is a geometrically nonlinear analysis. Then you have to click on to turn it on, and go to the increment, and here you can change the maximum time increment to, for example, 0.1. Click on OK, and here check the field output. We have everything about stress, strain, displacement, force, and contact. We don't need contact here, and you can unselect this one. Okay, here you can change the frequency to every X unit of time, and put 0.1 here as well. Click on OK, and close this window as well, and open the history output. Click on edit, and here you can select this one, every n time increment, and you can apply 1 here. And as you can see, these are the energy absorbed by the structure. You can select this item as well. Click on OK and close this window. Go to the, we don't have any interaction here, and directly we are going to the load modulus. Here in the load modulus, click on the create boundary condition, and here choose the displacement rotation and click on we have to do something here. As you can see, this boundary condition applied on the earthquake step. First, we have to go to the initial step, which is before the earthquake, and apply some boundary conditions here, then go to the earthquake boundary conditions. So here first we change the initial step here and click on displacement and continue. Okay, here I'm going to select these areas. Here, press shift, here, here, these areas. Press shift and select all these areas. Okay, click on done, and here we are going to apply the earthquake acceleration on the X direction. Then we select all of these direction to be constrained but except Z direction. Click on OK. Okay. Now we have to apply the earthquake acceleration here. Click on create boundary condition once again and go to the acceleration, here we have to select earthquake step, because this boundary condition or this kind of loading is for the earthquake step. Then click on continue. Once again you have to select those areas. Press shift and select all these areas. Okay, click done. And here we want to apply the earthquake acceleration on the X direction. Then we turn it on and apply 9.81 as the Earth's gravity. And also here we have to click here, choose the tabular, and click on continue. We have to enter the time and amount of acceleration here, and then we select these columns and copy these columns to here in the ABAQUS software and click on OK. This is our amplitude 1, and we select this amplitude 1, which is the weight, and this is going to multiply this gravity amount to apply as a acceleration here. Click on OK. As you can see here, this acceleration applied here on the structure to simulate the earthquake effect. Okay, now we have to go to the mesh part and here select the mesh. Okay, here as you can see, all the structure is in the orange color, which means that you cannot mesh it by quad elements. So we have to do some partitions first, then we can mesh it by a quad structural elements. So for that you can select this one, click it, push it, and then choose this partition cell, extend face. Okay, you can select this area and then create partition. As you can see, this structure partition from this face, and also and then click on this part, done, and now choose this area, create partition. And now we have two partitions, as you can see. Click here, done, and choose this line, this area, sorry, and turn it that you can see the bottom of the structure. Okay, now you can select this part of structure, click on done, and use this area for partition. You can see it turns to green. It means that you can mesh it by structural quad elements. So select this one and click on done and select this area for partition. Okay, this, done, this area, okay, this area as well. Okay, now you can see that some parts turn to green, which is the best shape for the quad elements, and we have some in red, we have some in yellow, but still we have some shapes in orange. That means that we have to follow our partitions. Okay, now I'm going to make some partitions through this line, through this axis, the z-axis I mean. Okay, I select all. First, be sure that you click on this bottom and then select all the structure. Okay, now click on done, and now choose, for example, this face for partitioning more. Okay, once again choose the whole structure, click on done and choose this face for more partition. Okay, done. Nice. Now do it from the other side, okay? Select this one, choose all, press OK. Once again, just this. Okay. Okay. All this structure turns to green, which means it's okay. Okay. Now we click on the seed part and choose the seed to be 0.5. Okay, very good. Here you can select your mesh type. It is 3D stress, it's okay, but you better to select explicit because it's an explicit analysis. Click on OK. And now it's time to mesh this structure. Like this, it's very beautiful. As you can see, it's very nice. It looks very nice. Okay. Now we can go to the job module and create a job. For example, here, earthquake. Type here, press continue and OK. Now submit the analysis to the software. I'm open the monitor window here. To avoid wasting your time, maybe it's better to stop the video and sure after completing the analysis I'm coming to show you the results. Okay, now it's done and we are going to check what's happening to see the results. Click results here and now you can see what is going on. Here is the stress pattern of the building here. You can change it to the displacement as you can see here, and also let's see the earthquake effect on the building. I'm going to make it a bit slower. Okay, and this is also the stress amount. And you also can bring reaction forces, but you have to click on blood symbols on like this. It's like this. This one is the acceleration diagram. But the most important things here is that the stress concentration points by the earthquake comes from these columns. And the first floor is bear the largest amount of stress in this building. And here you can select all the total energy, for example, during the time. As you can see, the total energy absorbed by the building like this, and also you can get the strain energy and the other parameters you can get. Yeah. Hope you guys enjoyed this video, and please subscribe my channel if you want to more related scientific experience of mine.